Okay, so this first lesson is going to be a bit of a review from Algebra 1. So we have a line here in slope-intercept form. The first piece is the slope, that's always the coefficient on x, and then the y-intercept is what's afterwards. Now when we graph these lines, we start at the y-intercept, which is of course on the y-axis by definition, and then we're going to follow the slope. Remember that the slope is the same thing as rise over run. So 3 is the same as 3 over 1. This is the same as 3 over 1. So we're going to go up 3 from the point that we know is on the graph, which is the y-intercept. We're going to go up 3 and then over 1. And that's where we know a second point must be. And we can continue doing this until we reach the end of our graph, and then we can connect the dots. We can also go the other way as well. So down 3 and then left 1 will also work. And then we connect our dots. So this graph here, or this line here, is the exact same line, but this time there's a greater than symbol. Now if your symbol is greater than or equal to, if it's greater than or less than, I'm thinking of a different lesson that I just did, your line should be dotted. So if it's greater than or less than, if there's no or equal to bar like this last example, if it's just a greater than or a less than symbol, like this, if it's just greater than or less than, then your line should be dotted. So we're going to do the same thing. We're going to graph this line exactly the same way as we normally would. So we're going to start from the y-intercept, and we're going to go up to 3, 1, 2, 3 over 1, 1, 2, 3 over 1. We're going to connect the dots, but this time, instead of doing a solid line, we're going to do a dotted line. We can also call this a dashed line. Mathematically, what this means is that solutions do not lie on the line. So where do they lie? Well, because this is a greater than sign, we're going to be shading everything above this line. And I do mean vertically above. So basically the rule of thumb is you put your pencil or your pen on the line, and if it's greater than, you shade up, so you can move the pencil up, and that's the area that you shade. If it's less than, you move the pencil down, and that's the area you shade. So in this case, because we're dealing with greater than, we're going to shade above. And so the solutions, because this line is dotted, the solutions do not lie on the line itself, but they lie everywhere within the shaded area here. So now for the last part. For the last part, we have h of x here, which is the same graph but with a less than or equal to sign. All right. So we have 3x minus 1. We start at negative 1. We go up to 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And note that this is a less than or equal to sign. If your symbol is greater than or equal to or less than or equal to, then your line is solid because solutions can lie on the line. So, just like with the first graph, we are going to connect these dots with a solid line. Not a dotted line, a solid line. But because it's not just an equal sign, there is still shading. So we're going to take our pencil, in this case I have a pen, and I'm going to move it down. Why did I move it down? Because this is less than or equal to. So because this is less than or equal to, I'm going to be shading values below. And so the solutions for this inequality lie anywhere within the shaded area and on the line itself. So this next part is a little bit misleading. You can type f of x, g of x, and h of x into Desmos, but for this one, you don't really want to type in f of x for this. If you type g of x and h of x in, though, you'll see that some of the graph is shaded. And feel free to do that. If you type in, now keep in mind, you're actually going to have to replace g of x with y. So instead of g of x is greater than 3x minus 1, you would have to type in y is greater than 3x minus 1 in order for it to show up. But you'll notice that some of the graph is shaded if you do this. All solutions lie within shaded areas or on solid boundaries or solid lines. So, pause the video, and I do want you to actually type this into Desmos. So instead of g of x, you're going to type in y is greater than 3x minus 1 and see where it's shaded. And you're going to type in y is less than or equal to 3x minus 1 and see where that's shaded. And I want you to figure out if 2 comma 3 is a solution to the first graph here, g of x, and I want you to figure out if 2 comma 3 is a solution to the second graph. Okay, so hopefully you've done that already. If not, please pause the video and do this yourself. Okay, so 2 comma 3. 2 comma 3 is right here. That's this point right here. And you can see that it is actually in my not shaded area here in the first graph, so it is not a solution of g of x, but it is in the shaded area of h of x. Okay, so now we have to talk about systems. So systems have two equations or two inequalities that use the same x values and y values. So they're typically plotted on the same graph, which is what we're going to do here. So we have 3x minus 1, the same graph that we've been plotting. 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. Solid line because it's an equal sign. I'm going to extend this one a little bit upwards. You'll probably notice why. This is a good idea to extend this particular graph up a lot, just so that you can properly see all four parts of it. You'll understand what I mean when I graph this one. So 2x plus 2. We're going to start at the y-intercept, which is positive 2. So we're going to start up here. We're going to go, the slope here is 2 over 1. 2 over 1. So we're going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, etc., etc. And we can connect these dots like this. And now you can see we have two lines on the same graph. They intersect right here. They intersect right here. And typically this is where the solution to the system would be. That is actually the solution to this particular system. But that's because we're working with equal signs. The point of these notes is to work with this one, which is what we'll get to in a second. I also want you to notice that we've divided this graph into four parts. We've got this part on the left, we've got this part down here, we've got this part on the right, and we've got this small little part up here. So now we're going to do the same thing, but this time we have inequalities. So the process is exactly the same, but this time we have to worry about dotted versus solid, and we have to worry about shading. So for the first one, 3x minus 1, we're going to graph it the same way as usual. This one is greater than, so it's a dotted line. I'm going to go way up here. And this is shaded above, but I want you to lightly shade it above. Don't shade it super heavily above. Don't shade it super heavily above. Then for the next one, we have 2x plus 2 once more. 1, 2 over 1, 1, 2 over 1, 1, 2 over 1, 1, 2 over 1, 2 over 1, roughly. And this is a solid line because this is less than or equal to, and that we're going to lightly shade this one below. So you see that we have this side on the left, or this part on the left that is just shaded once, this part on the right which is just shaded once. The part on top is not shaded at all. Yeah, if you look really closely, the part on top is not shaded at all. So the points in here are not solutions to either one of these. And we have this shaded area right here, which is shaded twice. And this is the most important area here. This area, the double shaded area, is called the feasible region. So this has the name, the feasible region. And this is where all of the solutions to the system of inequalities lie. So if we have one part of the graph that's shaded lightly, and another part of the graph that's shaded lightly, then the solutions to the system will actually be within both shaded areas or on solid boundaries. So right here. So the only points that are solutions to the system, the whole system itself, are the ones in the double shaded area. Not over here, not over here, just in the double shaded area. So, is -1 comma -1 a solution? -1 comma -1 is right here. It's in the double shaded area, so that is a yes. Is 2 comma 4 a solution? Well, 2 comma 4 is just outside of the double shaded area, so no, it is not. And is 0 comma 2 a solution? Well, 0 comma 2 is actually on this dotted line here. And because it's on a dotted line, the answer is no. If it were on a solid line, the answer would be yes. So if this were, say, equal to, if this had an or equal to bar underneath and this line were solid, then the answer to this would be yes. But because it lies on a dotted boundary, the answer is no. Now, if you want to check these, you can type this system into Desmos. You type the first equation on one line and the second equation on another line, and then you can check to see if each of the points are in the solution, or in the feasible region. So I would recommend doing that if you are bad at graphing these lines, if you're not exact at graphing these lines. I would also recommend using a ruler for graphing these lines. I think that that helps a lot. I didn't, but I have a lot of practice. So a ruler definitely helps with this. But yeah, so I want you to complete the graphing inequalities and graphing systems of inequalities formatives.